Everyone, I am Dr. Ravina Priyadarshini. In today's class, we shall discuss about the frequency modulation. So, frequency modulation is a type of continuous time modulation. So, here we can say that for the modulator, it has two inputs. So, one is the message signal, another one is the carrier signal. So, as usual, message will be a low frequency signal and carrier will be a high frequency signal. So, by definition, frequency modulation is defined as the amplitude of the carrier signal is the frequency of the carrier signal is varied in accordance with the amplitude of the message signal. So here normally the signal which has three parameters: amplitude, frequency and phase. In case of frequency modulation, we can say or we can define the frequency of the carrier signal is get varied in accordance with the amplitude of the message signal. And here only the frequency term of the carrier will be get varied and amplitude and phase of the carrier signal remains constant. So there will not be any changes in the amplitude and the phase components. Only variation will be in the frequency component. So uh, while transmission, in many cases the noises will be added in the amplitude. So since we are using the frequency modulation, this modulation scheme it should provide better performance when compared with the amplitude modulated signal. So this is the waveform representation. It consists of three signals. One is the message, next carrier, and the FM modulated signal. So as we see, the message signal, it's a low frequency signal. So it's a sinusoidal signal whose amplitude is AM, which remains for a time duration of T. Next is the carrier signal. The carrier signal is a high frequency signal. So for the same T time duration, the signal has a more number of cycles, which indicates that the signal will be a high frequency signal. Here the amplitude of the carrier signal is considered to be AC. Next is the frequency modulated signal. So when these two signals are transmitted through the modulator, the output will be the frequency modulated signal. And in case of frequency modulated signal, it is represented as for the particular time duration, the frequency of the signal carrier signal is get varied. So when we compare the second figure and the third figure, the amplitude term of the carrier signal remains constant. So here there is no variations in the amplitude term. What is the amplitude of the carrier? The same amplitude will be the amplitude of the modulated signal. So we have considered that the amplitude of the carrier as AC, then the amplitude of the FM signal is also AC. So it will not change for the entire time duration. It is constant. And in case of frequency, here we are represented that for increasing when we compare the message signal, if the amplitude of the message signal is increased from 0 to the maximum peak, the frequency used to represent will be a high frequency. And once the signal reaches its maximum amplitude value and the amplitude of the message signal decreases up to the negative half cycle, the frequency of the modulated signal is also low, which indicates low frequency for its transmission. And once again, if the signal from the negative peak goes on increasing towards the positive half cycle, so if the message signal is get increased, or if the amplitude of the message signal is get increased, then the we are using more number of high frequency signals to represent the carrier signal will be indicated by the high frequency signal. So likewise, the graphical representation of the signal is represented. So next is the equation of the FM signal. So we can say that Fi instantaneous frequency in FM, which is equal to Fc plus Kf into m of t. So m of t is the message signal and Kf is the index. Therefore, the relationship between the angular frequency and angle of theta is represented as theta of t is equal to 2 pi f into Fi of t, 2 pi integral Fi of t into dt. So when we are substituting value of fi in the above equation, theta of t is equal to 2 pi integral fc plus kf m of t into dt, where theta of t is equal to 2 pi fc t plus 2 pi kf into integral m of t into dt. So when we are substituting the theta of t from the above equation, s of t is equal to ac cos 2 pi fct plus 2 pi kf into integral m of t dt. This is the equation of FM waveform. So if the modulating signal is m of t, which is equal to am cos 2 pi fm t, then the equation of fm can be represented as s of t is equal to ac cos 2 pi fct plus beta sin 2 pi fm t. So next is the modulation index. So modulation index indicates the depth of the modulation, so which is the change in frequency to the instantaneous frequency of the message signal. So here delta f, which is represented as kf into am divided by fm. Next parameter is frequency deviation. It is defined as the ratio difference between FM modulated waveform frequency and the normal carrier frequency. So it is denoted by del f. And next deviation ratio. So according to the FM deviation ratio, it can be defined as the ratio of maximum carrier frequency deviation to the highest audio modulating frequency. So let m be the deviation ratio, which is equal to the ratio of maximum frequency deviation divided by maximum modulation frequency. Next is the bandwidth of FM. So bandwidth of FM, it is defined based on the types of FM. You can say that it's a narrowband FM or wideband FM. In case of wideband FM, the bandwidth will be a infinite number of bandwidth, and in case of narrowband FM, the bandwidth is same as that of the amplitude modulated signals bandwidth. Therefore, by using the Carson's rule, states that bandwidth of FM signal is double the sum of maximum frequency deviation and highest modulating frequency FM. Thus, if the bandwidth is, if you represent B based on the Carson's rule, B is equal to 2 into FD plus FM. Thank you.